Very good morning to all of you. Welcome to GATE Academy Global and Unacademy. So today we are going to discuss some questions of a topic that is core losses in transformer, one of the most important subtopic of transformer. So here we are having a first question. In this particular question, it is given that the full load copper loss and iron loss of a transformer are 6400 watt and 5000 watt. The copper losses and iron losses at the half load will be. So let us start it now. So the full load copper losses is 6400 and 5000. Now they are asking about the copper loss and iron loss at the half load. As we know that the copper losses depends upon the load current, whereas iron loss is independent of the load current. That means the copper losses changes with the load, whereas the iron loss does not change. That means if the iron loss is given 5000 watt, it remains same at the half load. That means if Pi equal to 5000 watt, it remains same. So from this option we can assume that the option D is the right one. Whereas to find out the copper losses, as copper losses depends upon the load, so it will change at the half load. Copper losses is already given, that is PCU equal to 6400. That is a full load copper losses, and we know that copper losses equal to X square times PCU FL. Now at half load, that means X equal to 0.5 square into full load copper losses, that is 6400. So the value will be 1600 watt. So at half load the copper losses will be, that is 1600 watts. So D option is the right one. Now question number 2. The hysteresis and eddy current losses of a single phase transformer working on 200 volt 50 Hz supply are PH and PE respectively. The percentage decrease in this when operated on 160 volt and 40 Hz. Before solving any question of the core losses of transformer, first we have to find out whether the voltage by frequency, the ratio of voltage by frequency is constant or not. So in this, at first condition, it is given that the hysteresis and eddy current loss of a single phase transformer working on 200 volt 50 Hz. That means initially the voltage is 200 volt and frequency is 50 Hz. At this particular voltage and frequency, it is given that hysteresis loss is PH and eddy current loss is P. So they are asking that what will be the hysteresis, the change in the hysteresis, that is percentage decrease in the hysteresis and eddy current loss when the voltage would be 160 volt and frequency, that is 40 Hz. So first of all we have to check whether the ratio of voltage and frequency is constant or not. So here it is, that is V by F. We have to put its value, that is 200 by 50, that is 4. And here V dash F dash, V dash upon F dash equal to 160 upon 40, that is also 4. So V by F, the ratio of V by F is constant over here. We know that voltage is approximately equal to induced EMF, that is equal to 4.44 F phi m into N. That means phi m is approximately equal to voltage upon 4.44 F into N. That means phi m is directly proportional to V by F, and we know that peak of the magnetic flux density is directly proportional to peak of the flux is directly proportional to V by F. If V by F remains constant, the phi m, the Bm also remains constant. The formula for hysteresis and eddy current loss. Iron loss consists of two losses. That is hysteresis loss and eddy current loss. Hysteresis loss, that is pH, equal to KH Bm raised to power x into F. KH is a constant, Bm is the peak of the magnetic flux density, x is the Steinmann's constant, F is the frequency. Whereas in eddy current losses, P equal to Ke Bm square F square. In this particular case, the ratio of voltage by frequency is constant. That means Bm remains constant. If Bm remains constant, hysteresis loss is directly proportional to frequency, or eddy current loss is directly proportional to frequency square. Or we can say that let's take a particular value, a constant A and B. A and B. Now, in first case the frequency is 50 Hz, in second case the frequency is 40 Hz. So, pH equal to A into 50, eddy current loss P equal to B into 50 square. In second case, pH dash equal to A into 40 Hz, it becomes 40 Hz, PE dash equal to B into 40 square. Now percentage change in frequency, percentage change in frequency, that is equal to, percentage change in hysteresis loss, in hysteresis loss, that is pH dash minus pH upon pH into 100, or we can say that pH dash upon pH minus 1 into 100. Now put the values of pH dash and pH, that is pH dash is A40 upon pH, that is A50 minus 1 into 100. So what will be the value? That is minus 20%. That is a percentage change in hysteresis loss, that is minus 20%. Now, percentage change in eddy current loss, that is equal to PE dash minus PE upon PE into 100, that is equal to PE dash upon PE minus 1 into 100. Now put the values of P dash, that is B40 square, B into 40 square upon B into 50 square minus 1 into 100. So cancel out the B. Now it becomes minus 36%. Minus means the eddy current loss and hysteresis loss both are decreasing, and as we know that hysteresis loss and eddy current loss both are directly proportional to frequency and frequency square respectively. That's why if frequency reduces from 50 Hz 40 Hz, both would reduce, and in this particular case the hysteresis loss would reduce by the 20%, whereas the eddy current loss would reduce by the 36%. So now if we check the formula, if we check the option, so B option is the right one, that is 20 and 36. One of the most important subtopic of transformer, which is frequently asked in the GATE. If you analyze the previous year questions, you will find that. Okay, now next question. Question number 3. A 50 Hz transformer having an equal hysteresis and eddy current losses at rated excitation is operated at 45 Hz at 90% of its rated voltage. Compared to rated operating condition, the core losses under this condition will be. Now, what is given over here? Let's take the rated voltage is V and frequency f equal to 50 Hz. At a 50 Hz transformer having an equivalent hysteresis eddy current losses at rated excitation, that means when rated voltage V and rated frequency 50 Hz is provided, the hysteresis loss equal to eddy current loss equal to P is operated at 45 Hz. Now it is operating at 45 Hz, that means f dash equal to 45 Hz and voltage is 90% of the rated, that is 0.9, V dash equal to 0.9 of the V. Compared to the rated operating point, the core losses under this condition, that means they are asking about what is the percentage change in the core losses from rated condition to this particular condition which is given. So in this question again we have to first of all check that whether V by F, the ratio of V by F is constant or not. Now in this, the ratio of V by F is what? That is V upon 50. Here V dash upon F dash, that is equal to 0.9 V upon 45, or we can say that V upon 45 divided by 0.9, that is equal to V by 50. That means in this question also the ratio of V by F is kept constant. That's why hysteresis loss is directly proportional to frequency and eddy current loss is directly proportional to frequency square. A and B are the constants. Now it is given that when the rated voltage and rated frequency is provided, the hysteresis and eddy current losses both are equal. Let it be a P. So initially at this particular condition, hysteresis loss, that is P equal to A into F and P equal to B into 50 square. Total core losses PC equal to what? PH plus PE, that is equal to PC equal to what? 2P. We can say that 2P. Now in second condition, PH dash equal to A into 45, PE dash equal to B into 45 square. Now we have to convert all the values in terms of P, because initially in the rated condition it is given that the total core loss is 2P. So we have to change all the values in terms of P. For that we have to compare the hysteresis loss and eddy current losses individually in comparison to that of the rated condition. Now in this, PS dash upon PH equal to A45 upon A into 50. So PS dash equal to 40 by 50, that is 0.9 almost. Yes, 0.9. So it becomes 0.9 times of pH, and pH is what? P. So we converted this hysteresis loss in terms of P. Similarly, we have to convert the eddy current losses in terms of PE, that is P also. So P dash upon PE equal to B45 square upon B50 square. 0.81, I think so. 45 divided by 50 square, 0.81. 0.81. So I also converted this eddy current losses in terms of P. Now, initially in the rated condition, the hysteresis and eddy current losses is P. So total core losses is 2P. Now, in second condition, PC dash equal to hysteresis plus eddy current loss. That is 0.9P plus 0.81P. So it becomes PC dash equal to 0.81 plus 0.9. That is 1.71 in terms of P. We have to find out the percentage change in core losses. So percentage change in core losses. Percentage change in core loss, that is equal to PC dash minus PC upon PC into 100. That is equal to PC dash upon PC. PC dash is what? 1.71P upon 2P minus 1 into 100. Cancel out the P. It becomes 1.71 divided by 2 minus 1 into 100. That is minus 14.5%. Minus 14.5%. So minus indicates that the core losses decreases, or here in the option it is specified that is reduced by 14.5%. So C is a correct answer. Now question number 4. So now we are moving towards the question number 4. Question number 4. The core loss of a single phase 230/115 volt 50 Hz power transformer is measured from a 230 volt side by feeding the primary 230 volt from a variable voltage variable frequency source while keeping the secondary open circuited. The core loss is measured to be 1050 for 230 volt 50 Hz input. The core loss is again measured to be a 500 watt for 138 volt 30 Hz input. The hysteresis and eddy current loss of the transformer for 230 volt 50 Hz respectively are. In this particular question, for 230 volt and 50 Hz, it is given that the core losses is 1050 watt. That means when V equal to 230 volt and frequency equal to 50 Hz, the core losses is 1050 watt. Now, when the voltage would be 138 volt and frequency 30 Hz, that is V dash equal to 138 volt and frequency would be 30 Hz. So the core losses becomes PC dash equal to 500 watt. Again, for any core loss, any question of the core losses, first of all you have to find out whether the voltage, the ratio of voltage by frequency is constant or not. So in this particular case we have to check that whether V by F is constant or not. So first of all here V by F, that is equal to 230 upon 50, and in this V dash by F dash, that is equal to 138 by 30. So first of all we have to check the whether V by F ratio is constant or not. So here it is, that is 230 divided by 50, that is 4.6. That is also 4.6. That means the ratio of V by F is constant. If the ratio of V by F is constant, so the hysteresis loss is directly proportional to frequency and eddy current loss is directly proportional to frequency square. So here that is pH equal to AF and P equal to what? BF square. So according to the data given for the first condition, that is for the rated condition, if the frequency is 50 Hz, the core loss is 1050. So 1050 equal to hysteresis plus eddy current loss, hysteresis loss, that is A into F. F is 50 Hz plus eddy current loss B into F square, B into F square, that is 50 Hz. Similarly, for the second condition, the total core loss is 500 watt, that is equal to hysteresis loss, that is pH equal to AF, A into frequency is what? 30 plus eddy current loss, that is BF square, B into F square, that is 30 square. So two equation, two unknown. We have to find out the value of A and B. A and B. So it becomes, that is A is 10.16666, that is 1.7, or 0.21666, so 217. So here the value of constants A and B is this one. Now we have to find out in this particular question, that is what is the value of hysteresis eddy current loss for 230 volt and 50 Hz. At 50 Hz, that we have to find out the value of individual hysteresis and eddy current loss at the condition of voltage 230 volt and 50 Hz. That means we have to put this value, hysteresis loss, that is pH equal to A into 50, that is equal to A is 10.17 into 50. So 10.17 into 50. That is 508.5 watt. Similarly, eddy current loss, that is B into 50 square, that is 0.217 into 50 square. So it becomes 542.5 watt. So the option A is correct one, that is 500 watt and 542 watt. Now question number 5. Question number 5. So we are now moving towards question number 5. A open circuit test is performed on 50 Hz transformer using variable frequency source and keeping V/F ratio constant to separate its eddy current loss and hysteresis loss. The variation of core loss upon frequency as function of the frequency is shown in the figure. The hysteresis and eddy current losses of the transformer at 25 Hz are. In this particular question, it is also the question of core losses, but in this particular question, it is already specified in the question that the ratio of V/F is kept constant. If the ratio of V/F is kept constant, that means hysteresis loss is directly proportional to frequency and eddy current loss is directly proportional to frequency square. In this particular equation, A and B are constants. Now, in this particular graph, which is already given in the question, it is the graph, it is the characteristic between core losses per frequency, that is watt per hertz, that is PC by F, with respect to frequency. We know that the core loss is PC equal to what? PC equal to hysteresis loss plus eddy current loss, that is equal to AF plus BF square. If we take common frequency from this equation, so it would become PC upon F equal to A plus BF. And in this particular graph, it is given the variation of PC by F PC by F with respect to frequency, in which it is given that when frequency is 0, PC by F is 10. When frequency is 0, PC by F is 10. And when frequency is 50 Hertz, the PC by F is 15. So, with the help of this particular data, we are now able to find out the value of A and B constants. Let's put this value in this particular equations. When frequency is 0, so when frequency is 0, so PC by PF, that is 10 equal to A plus 0. So the value of A is 10. Now when frequency is 50 Hertz, PC by F is 15. So it becomes 15 equal to A plus B into 50. So 15 equal to A, that is 10, plus B into 50. So the value of B would be 0.1. 0.1. So B would be 0.1. Now, what we have to find out in this particular question? The hysteresis and eddy current losses of the transformer at 25 Hertz. Now it is at 25. Now, hysteresis loss at F equal to 25 Hertz. So hysteresis loss equal to what? A into F, that is equal to A, that is 10 into 25, that is equal to 250 watt. So hysteresis loss becomes 250 watt. Whereas eddy current loss, P equal to BF square, that is equal to B 0.1 into 25 square. Square into 0.1, that's 62.5. So eddy current losses becomes 62.5. That means at frequency 25 Hertz, the hysteresis loss would be 250 watt and eddy current losses would be 62.5 watt. Now let's check the options, 250 and 62.5. 250 and 62.5, that is B is the correct option. Now, so at the end of the class, I have to give you information about our latest courses. So from Unacademy, master your gate preparation with live gate classes by Gate Academy. So Gate Academy is now providing you your classes at a very affordable price, that is 4,499. But this particular discount is only valid till 9th of December. That is the early bird price, that is 4,499. That is valid only till 9th of December. If you want to prepare it for the 30 months or you want to take this course for the 30 months, then the price would be 6,499, but it is also till 9th of December. After 9th of December, the rate of the course would be 6,110 and 8,332 for the 30 months. For additional discount, you have to use the code, that is GA1111, in which you will get a tremendous, very good content by our top educators, So here The master your GATE preparation with live GATE classes by GATE Academy. India's best educators you will get in class practice to strengthen the concept, interactive live classes, structured course in PDF, raise a hand, doubt solving. This particular feature of the Unacademy class is brilliant. Now, if you opt for the recorded courses, self-study recorded courses, now the Unacademy is providing you a good content in a self-recorded, self-study recorded courses. Also, if you are going for the electrical and English course, Unacademy is providing you 1095 hours of content, 1095 hours of content at a very nominal price. The price would be, that is 5,499 for 15 month subscription and 7,499. But remember that you have to use the code GA1111 for 10% additional benefit. Similarly, if you opt for the English course, that means Hindi plus English. If you opt for that, you will get the recorded course of GATE of content of 1513, that is 1513 hours at a very nominal price. If you opt for the 15 months, that is 3,999, and for 30 months it would be 4,999. And if you want additional 10% discount, you should go with the code GA1111. If you want the GATE-like experience for GATE and ESE aspirants, we are going to conduct an exam at 4th December, 18th, then 8th January, 15th January, 22nd January, 29th January. So with the help of this particular exam, you could know that where you stand with an all India rank, practice with tests curated by top educator, GATE detailed performance report with the video solution. Again, you have to use the code GA1111. You should also know that we are also launching the Pratigya batch, which is one of the best batch provided by the GATE Academy top educators. So it is going to be started from 15th of December. Signal system by Sujoy sir at 7 p.m. If you want the live classes, because the previous courses was recorded one, but this particular course is the live classes, live GATE classes, that is provided by the GATE Academy educator. So if you want to subscribe for the Pratigya batch, so you have to also use the code GA1111. So thank you all of you. We are going to meet you soon for the next class, in which we are going to discuss a different subtopic of very important of the machines subject. Thank you so much.